Good day. I am Jamila Elaine M. Alves, and I would like to present to you my thesis entitled The Pyrolysis of Coffee Pulp as Potential Bioenergy Resources. But before that, I would like to sing the PSA hymn. At the foothills of the mountain, the cradle of the mind, spring of wisdom, found of hope for the future of the land, to enable and empower all who wish to blow and grow, to explore and soar the heights, to prosper with the land. At PSAU the land is dear, at PSAU the land finds hope, at PSAU we all are led to greatness and excellence. We will raise our heads with pride, and we pledge our loyalty to its dream and to its mission. Help sow the seed for a better world. With the blessings from above, God who waters with the rain, make the sun to rise for growth, and we thank Him for this all. At PSAU the land is dear, at PSAU the land finds hope, at PSAU we all are led to greatness and excellence. We all raise our heads with pride, and we pledge our loyalty to its dream and to its mission. Help sow the seed for a better world. Pyrolysis of coffee pulp as potential bioenergy resources. So, for our introduction, biomass is one of the well-utilized sources of renewable energy in the world. Main type of biomass are wood, forest and agricultural residue, herbaceous species, manure, and aquatic biomass, according to McKendry 2020. To date, the demand of the renewable energy is increasing. The biomass is a renewable resource with a great potential as an alternative to a fossil fuel for supplying energy, by Hashimoto, Hasegawa, Hayashi, and May 20. One way to convert the biomass into convenient and effective fuel is pyrolysis. The pyrolysis is coined from the Greek word pyro, which means fire, and lysis, which means a separating. Pyrolysis is a thermal process producing liquids, which by oil, solid, biochar, and gases in the absence of oxygen. Coffee pulp, also identified as coffee fruit without seed or bean. It is an abundant agricultural byproduct. It represents around 43% of the weight of the coffee bean on a fresh weight basis, or approximately 28% or 26 to 30% of the coffee bean on dry weight basis. The general objective of the study was to evaluate the potential of coffee pulp as bioresource energy. Specifically, the study aimed to, first, to evaluate the effects of temperature and pump speed on the yield of the bio-oil and biochar. Second, characterize the product in terms of its thermochemical properties, heating value, proximate analysis, and elemental composition. Third, calculate the mass balance and energy conversion. And fourth, conduct cost analysis or the cost of raw material preparation. For our methodology, the process flowchart of the study was the material preparation, setting of pyrolysis, process of pyrolysis, data gathering, characterization of the product, statistical analysis, and the cost analysis. The study was aimed to evaluate the potential of coffee pulp as bioresource energy and the characterization of biochar and biooil in terms of their thermochemical properties, and evaluation of the effects of the temperatures and pump speed on the yield of the product. Unfortunately, the study needs to put off to a later time due to an unexpected enhanced community quarantine or ECQ that was imposed because of the coronavirus disease or COVID-19. The first picture shows during the harvesting of coffee. 29 kilos of fresh coffee bean was harvested from coffee plantation of Pampanga State Agricultural University. And also that day, the researcher removed the pulp from the bean using the depulper machine of the PSA. After the pulp was removed from the bean, the coffee pulp was go through a cleaning stage to remove dirt and residues. After that, the collected coffee pulp was weighed before and after going through sun drying until the coffee pulp reaches the equilibrium moisture content or EMC for 1 week. The dried biomass coffee pulp, which was already weighed and was pulverized using the grinder of the PSAU. The pulverized particle was in the shift set and shaker, size 1.5 mm for 40 seconds, then followed by the final weighing of the pulverized biomass before going through pyrolysis. After pulverizing the pulp, the batch type reactor was used. The equipment that was used in the study was the PAR 4520 benchtop reactor with PAR 4848P controller and a nitrogen tank manufactured by PAR Instrument Company. This reactor has a cylinder container that holds a capacity of 100 grams. For the pyrolysis, a sample weight of 100 grams per treatment was placed in the cylinder container, wherein the cylinder was mounted into the vessel of the reactor. The nitrogen tank was opened at 15 psi and will purge out the oxygen inside the vessel for 5 minutes. Then, the temperature was set varying from 300 degrees Celsius, 400 degrees Celsius, and 500 degrees Celsius with a minimum residence time, while in the stirrer speed was set varying from 120 rpm and 160 rpm. But due to the implementation of lockdown, the researcher didn't finish the study. The researcher conducted only 3 treatments that's supposed to be 6 treatments. The first 2 treatments did not produce oil, while the last treatment conducted produced oil, but only 2 replications are done. Also, the researcher didn't start the study early because the harvesting of coffee pulp in PSAU was on mid-January to February. Things that the researcher needs to accomplish. First is the pyrolysis. 10 samples are needed to go through the pyrolysis. Next is bomb calorimeter testing. 36 samples need to be tested. Next is the maple furnace testing. 36 samples needed to be tested. And lastly, data gathering and editing of manuscript, transferring all the data to a clean record. The researcher planned to continue the study once the Enhanced Community Quarantine or ECQ is lifted. 8 out of 10 samples are done in pyrolysis, and the testing of samples are not yet done. Thank you. And God bless. Bye-bye. Bye-bye.